Yeah, thank you. Yes, thank you so much for having me. Yeah, it is. Let's see. It's hopefully it's interesting. It's a lot of content. I have to apologize in advance.
Okay, no need to apologize. I think it's great, and I've got a lot of feedback from last week's conference too. Just I think more and more people are interested in
Mhm.
more systemic change rather than just practices and practices only. So um, I joke around like these are the conferences that I would want to go to, so I organize them so I don't have to look for the ones. It's also tough to find like I try to bring people from different disciplines. Uh,
Mhm.
Eric doesn't
Yeah,
necessarily.
organize. Thank you so much for doing it. I guess organizing conferences is especially if you have to do it like on your free time, right? It is, we also have to follow jobs somehow. And yeah, I know that it's taking some time and effort and energy, of course.
It does, yeah, but I'll try to keep it simple, so that helps.
Yeah, that's good.
So I think it's 11:59 Eastern time. It's what time is it for you? 6 p.m.
Yes,
Yeah,
6 p.m.
yeah, let's get started.
Shall I start?
I think so. It's
Great. Thank you so much again for having me. And welcome everybody to this talk about adaptive socio-technical systems with architecture for flow. So I have to figure out, I'm sorry, I have to rearrange some screens. Let's see. This works. So when building systems in general, we face the challenge between building the right thing, building the right product, and also building the thing right, building the product right. And building the right thing addresses effectiveness and addresses questions such as how aligned is our solution to our user and business needs? Are we generating value for our customers? Have we understood the problem? Do we share a common understanding of the problem of our customers? And on the other hand, building the thing right that focuses more on efficiency, for example, efficiency of engineering practices. And it's not only crucial and important to generate value for our customers, but also being able to deliver that value to our customers. And how fast can we deliver changes, and how fast and easy can we make a change effective and adapt to new circumstances? But the one effectiveness does not go without the other, efficiency. And but as Dr. Russell Eckhoff, one of the pioneers of systems thinking, mentioned, is that doing the wrong thing right is not nearly as good as doing the right thing wrong. So building a wrong product in an efficient manner is still worse than building a right product inefficiently. Or as John Cutler says, crap delivered quickly is still crap, unless we learn something from it and we can then also act on that learning. So to build the right thing right, we need to build adaptive socio-technical systems that are optimized for fast flow of change, for fast flow of value, and constant feedback. And one approach that out of many that can help us with that is combining Wardley Mapping, domain-driven design, and Team Topologies as architecture for flow. To build the right thing, to address effectiveness, that requires to start from the user perspective. Clayton Christensen, the inventor of the jobs to be done theory, stated that people buy products and services to get a job done. So in order to help users to get their job done, we first have to know who are our users of our solutions that we provide and what jobs they want to accomplish. And we also need to identify then the desired outcomes as the user needs that the users want to achieve when getting a job done. And jobs to be done and the user needs, they describe the problem space and will usually remain the same regardless of how the user needs are then solved in the solution space, as long as we solve the user needs effectively and efficiently. In the example of an online school solution for junior students, one of the user types are the teachers. And the teacher's core functional job is to facilitate remote learning. And to accomplish this job, the teachers need to prepare learning materials and also assess the student understanding with assignments. They need to track the student progress over time or facilitate communication with the students, and also ensure and set up a secure access to the learning platform, for example, with sign up and sign in processes. And in the solution space, those user needs are typically directly or indirectly fulfilled by a chain of components that generate value for the users by satisfying those user needs. And that's where we can blend in the value chain, the y-axis of a Wardley map, where the users and the user needs are representing then the anchor of the map. And deriving this value chain helps us also to ensure that we are addressing the right problems and create value that aligns closely with the user needs that we have identified earlier. And the value chain itself shows how the different components of our value chain connects, and also in order to generate value, and also visualizes their dependencies. And it can start simple with just a few components, and we can iterate later on as well and complement them. So in our example, in the example of the online school solution, the teachers, they are directly interacting with an online school component, and that is most visible to the teachers, and it's located at the top of the value chain. And this online school component also depends on other components. For example, in this case, in this simplified example, on foundational infrastructure components, and they are less visible to the teachers, and then located further down at the bottom, towards the bottom of the value chain. And then we are typically mapping those components of the value chain along the evolution stages on the x-axis. And the evolution stages are genesis with brand new things, then custom build, then product and rental, such as off-the-shelf products or open source software solution, and commodity and utility at the right. And each evolution stage come with different characteristics. So towards the left spectrum, towards genesis and custom build, the components change far more frequently than components toward the right spectrum, towards commodity and utility and product and rental. So on the left side, we are dealing with high level of uncertainties, with unknowns, and deal with undefined and poorly understood markets. While towards on the right spectrum, towards commodity and utility, the components become more stable, known, widespread, standardized, and the markets are typically well-defined and mature. And a Wardley map itself that helps to visualize the business landscape in which an organization is operating and competing in. And it is not supposed to be, a Wardley map itself is not supposed to be perfect, but provides a useful abstraction. So there's this one phrase like, all models are wrong, but some are useful. And that also applies to Wardley mapping. So sometimes also to my frustration, but you can't really have a perfect representation. It's just an abstraction. But a great value comes from creating this Wardley map together within a group. And that helps on the one side also to create a common understanding of the business landscape within this group, and also helps to challenge our own assumptions. And it also helps us to assess efficiency gaps. So, for example, we can then ask questions: are we custom building components that do not belong to our core domain, or can we utilize further evolved components, and so on? So there are a lot of questions that we can ask. And also it helps us to identify areas where to invest and where to innovate, or what to evolve and what to also outsource in order to gain competitive advantage. And I personally use the Wardley map as a visual tool, visual foundation to drive the conversation around the optimization process, to optimize our system for fast flow of change. So to build the thing right, now we're switching to efficiency, we need to optimize our flow of changes. And we can also use it as the Wardley map as a high-level entry point to assess the flow of changes, and can trace the dependencies in our value chain and analyze how a change would propagate through our system by analyzing, on the one side, what components would be involved in a change, and also what corresponding teams need to communicate and coordinate in order to make that change effective. But it can also be, that's just like a high-level entry point. Usually you can complement this, for example, also with value stream mapping. So in an ideal case, the teams shall fully own the entire end-to-end flow, from the first idea to generating and delivering value to our customers, and with minimal interruptions and with minimal bottlenecks along the way. And teams often know what is slowing down the work. So meeting teams where they are and interviewing them about what is currently blocking you in your daily flow of work helps then to identify the blockers to flow, and helps to identify what we shall minimize for our ideal future. And it's also worth to capture not only the blockers to flow, but also to capture those elements or activities that is supporting our flow of change, and can be then also collected in order to understand what we shall keep, what shall we preserve for our future to be state. But when we go back to our blockers to flow, we can analyze them from various perspectives. So when the teams do not fully own the entire end-to-end flow, from designing, developing, testing, releasing, and running their parts of the system they are responsible for, then they depend on other teams' activities and tasks to get their own work done. And then that requires to repeatedly hand over work to other teams at a later or earlier stage of flow in order to get their own work completed. So, but handover requires a high amount of communication and coordination efforts, and also potentially introduces then wait times and delays between the teams that is then also affecting our flow of change. And if teams are missing capabilities, when they're missing some skills, and if they need to bring in people with a specific expertise into the team, so that these people with this expertise have to do something in order to get our own work completed, that can also affect and impede our flow of change, particularly when the people we depend on are not available when we need them. And every dependency, specifically blocking dependency, that requires some level of communication and coordination efforts between the teams, and also increases the probability of waiting times and delays. And particularly when the people we depend on, when they are not available when we need them, or when the teams we depend on cannot keep up with the demands, with the volume of demands placed on these teams, and when the other teams we depend on are overloaded, so that the other team become a constraint and slow down the overall performance. So if teams have to interact with many other teams to get their own work completed, that can then potentially slow down their flow of change. And from a software architecture point of view, if we have tightly coupled architecture, then we are dealing with tight change coupling. And tight change coupling also impedes the flow of change, as, for example, changes in one part of the system can have unpredictable side effects on other parts of our system, which increases then the risk of breaking things and introducing defects and rework, which then also cause, like, depending on the urgency of these defects, then also causing interruptions and unplanned work. And from a software quality perspective, like technical debt, such as, for example, like poorly written code or lack of tests, high level of code complexity that leads then to fragile code bases that are hard to maintain long term. And coming back to team ownership, so a messy architecture with blurry and fuzzy modularity boundaries, they make it very difficult to establish clear ownership boundaries from the team perspective. And that can lead to a lack of ownership, which decreases also then the accountability for part of the system, which potentially also you can lead to not my job syndrome, and can cause like decision delays and impeding our flow of change. And with business logic mingled together in a messy model with no clear modularity boundaries, that could also increase the mental effort to understand a piece of code, and also including in this messy architecture, also including understanding the dependencies in this large intertwined system. And that could lead to teams then owning too many or too large intertwined parts of the system. And if that's the case, then it can lead to that their team's cognitive load exceeds. And if the team's cognitive load is largely exceeded, then it also becomes a delivery bottleneck. And when teams lack priorities and focus, they often try to work on multiple tasks at once, resulting then in higher work in progress and jumping between tasks back and forth without completing them. And also like frequent interruptions and unplanned work, for example, through the defects we have introduced to the tightly coupled architecture, that can lead then to a lot of context switches, which also affects our flow of change. So after we have identified the potential blockers to flow, one approach to address them or to unlock them could be by combining Wardley Mapping, domain-driven design, and team topologies as architecture for flow. And that brings us back to our previously created Wardley map. So to optimize for flow of change, we first need to analyze what will drive value and change within our organization. And that requires to identify where the most important changes in our system occur, the streams of changes. And the user needs of our Wardley map, they are good candidates of customer-driven streams of changes. So we need to structure our teams and our system around these customer-driven streams of changes in order to ensure a fast flow of change where it matters most. And the user needs are not only representing the streams of changes and also the anchor of our Wardley map, but also represent the problem domain. And that's where domain-driven design comes in. Domain-driven design helps us to gain a shared understanding of our problem domain, and it also helps us to partition our problem domain into smaller parts, into subdomains. But not all subdomains are equal. Some are more valuable to the business in terms of differentiation than other parts, other subdomains. So we have different types of subdomains. We have core, supporting, and generic subdomains. And the core domain, that is the essential part of our problem domain, providing competitive advantage. And that is the subdomain that we have to strategically invest in most, and where we should build its solutions in-house. And the supporting subdomain, they help to support the core domain, and they complement the core domain's offerings. But they do not provide competitive advantage, but are necessary for the organization to succeed. And they typically exist in other competitor solutions as well. So the supporting subdomains are non-differentiating. They provide no competitive advantage, but they are typically specialized. And if we have highly customizable products or open source software solutions in the market, if we have those in the market, available in the market, then we can focus on buying or using those for the supporting subdomains. But if the supporting subdomains or the solution of the supporting subdomains cannot be productized because they require a high level of specialization, then we have to custom build the supporting subdomain solution, but with the awareness that they are not differentiating. And generic subdomains are subdomains that many business systems have, not only our competitors, but many other systems as well. For example, authentication and registration that exist in a lot of other, I guess, in every other business solution. So, and they are not core. They provide no competitive advantage, but businesses cannot work without them. So, and generic subdomains are neither specialized nor differentiating. So buying or using off-the-shelf products or using open source software solutions or outsourcing to utility suppliers, that should be applied to generic subdomains. So the subdomain types, they help us to focus our strategic investments, focusing on the core domain related solutions and support us in our build, buy, and outsource decisions. So far we have discovered our subdomain types, and we get an understanding where we shall focus our development investments from a problem space point of view. But now when we switch to the solution space, the subdomains are currently all mingled together in a monolithic big ball of mud with a messy model and no clear modularity boundaries, which is causing, as we have addressed earlier, tight change coupling, lack of clear ownership, high team cognitive load, and also, we are custom building parts that are not core to our business. So we have an inefficient focus of development effort also on non-differentiating parts, which is also then, affecting our efficiency, and the others are blocking our flow. To address those, for example, to address the tightly coupled architecture, one aspect to consider is to leverage modularity with high functional cohesion and loose coupling. And by designing a modular, well-encapsulated, loosely coupled system. And that's where we need to decompose our online school solution with a monolithic big ball of mud into modular components. And that brings us to the second aspect of domain-driven design, to bounded contexts. And bounded context group related business behavior together and defines where a single domain model can be applied. And a domain model itself encapsulates particular business logic related to a specific subdomain. And a bounded context helps us to enforce or to high cohesion and modularity from a business behavior point of view. And they indicate good domain logic specific themes to split our system into smaller, modular, well encapsulated parts. And they also serve very well as ownership boundaries. We come to that one when we address the team perspective. So designing bounded context and their domain models, that involves a close collaboration between domain experts and development teams in order to gain a shared understanding of the domain. And there are different techniques available for modeling the domain. For example, event storming, domain storytelling, sample mapping, user story mapping, and more, and they can also be complemented. So we have discovered the subdomain types and designed our modular bounded contexts after we have, for example, applied some event storming sessions with domain experts. Now we are in the position to target our strategic investments better. And we can ask questions such as, are we custom building parts that do not belong to our core domain? And we can now then focusing our major development efforts around our core domain related bounded contexts that provide competitive advantage by building them in-house. And we can also, for our unspecialized non-differentiators, we need to evaluate whether we can use existing solutions. For example, for the generic subdomain-related bounded context of identity and access that that do not provide competitive advantage, and they usually consist of common standardized processes and functionalities that typically do not require a very high level of variation or specialization. So here we can leverage existing solutions, off-the-shelf products, open source software solution, or utility services that we can get from that are available in the market. But for the supporting subdomain-related bounded context, the decision whether to build or buy is a little bit more nuanced. So the supporting subdomain-related bounded context, they are non-differentiating but specialized. So, and they play a significant role in complementing the core domain's offering. So in case they are so specialized that they can't be productized, so when we have no products available or highly customizable products available, then it require custom development. But whether to leverage further evolved components, or we also need to assess the entire value chain, not only our bounded context, in order to increase efficiency. So in our example of our online school solution, we could decide to migrate our current on-premise infrastructure components to cloud-hosted services that are available as commodities. Migrating to cloud-hosted services helps us to increase efficiency and close identified efficiency gaps. So far, when we look back at our blockers to flow, we have unlocked blockers to flow that are currently related to software architecture and efficiency gaps. But considering the socio-technical aspect of our system, we also need to bring in the team perspective in order to unlock those blockers to flow that are related to team ownership, team dependencies, and team interactions between the teams. So that is where Team Topologies can help us with. And Team Topologies come with well-defined team types and interaction modes. So we have, on the one side, we have the autonomous cross-functional streamlined teams that are aligned to a continuous stream of work. Then they focus on a fast flow of change. And to be able to produce a steady flow of feature delivery and to be able to focus on a fast flow of change, they need the support from other teams, for example, from the platform teams. And platform teams support the streamlined teams delivering the work, and they are usually responsible. They are responsible for platforms that the streamlined teams can easily consume. And the platform can usually vary in its level of abstraction. For example, at a lower level, a platform can abstract away infrastructure, cross-cutting capabilities, and at a higher level, a platform can also reflect a design system, a data platform, and so on. So the platform teams, they provide internal self-services and tools for using the platform they are responsible for. Or the streamlined teams can get support from the enabling team that support the teams as internal coaches and help them to identify and acquire missing capabilities, have to upskill teams. Or the streamlined teams can get support also from complicated subsystem teams there as an optional team type, and they are supporting streamlined teams on particularly complicated subsystems that require very specialized knowledge, which is not worth spreading across all other teams. For example, mathematical models or low latency networks, video encodings, and so on. And they all aim for increasing the autonomy and reducing the cognitive load of the streamlined team in order, as an overarching goal, to enable a fast flow of change. But to arrange these teams and these team types is not enough to become effective. So how these teams are interacting with each other and when to change and evolve the interaction between teams is also relevant for high effectiveness. And with collaboration, teams are working very closely together over a limited period of time, and it's usually suitable for rapid discovery and innovation, for example, when experimenting with new technologies together. But collaboration is meant to be short-lived. Exists a service that suits well when one team would benefit from using a code library or a component, an API or platform that can be effectively provided by another team as a service. In facilitation, this interaction mode comes into play when one team would benefit from active help from another team, and this interaction mode is typical for enabling teams. So coming back to our Wardley map, now we are mingling the team perspective. The next step could be finding then suitable team boundaries that are aligned to customer-facing streams of changes. And as mentioned earlier, the bounded contexts serve very well as well-defined ownership boundaries for streamlined teams. So that makes then the bounded context, besides good seems to split a system apart into modular components, also good candidates for team ownership boundaries for streamlined teams. And to address the previously identified blockers to flow that are related to team ownership, we also need to focus on optimizing team cognitive load. To optimize team cognitive load, we have to limit then the number, the size, the complexity of software system a single team has to work with. And that also involves establishing clear ownership boundaries, where also bounded context can assist in achieving this clarity for ownership boundaries. But optimizing team cognitive load is not restricted to bounded contexts only, but applies again to the entire value chain, and to reiterate, to be able to focus on a fast flow of change. The streamlined teams, they rely on other teams supporting them delivering their work. For example, from platform teams providing platforms that the streamlined teams can easily consume in order to reduce cognitive load. And that requires to identify services that support a reliable flow of change and can be easily consumed as a platform, providing self-service capabilities, reducing team cognitive load. So in our example, the infrastructure components that in our Wardley map located in commodity and utility, they could be potential candidates suitable for forming a platform that can be effectively provided as a service by a platform team. And besides reducing team cognitive load, providing self-service capabilities that aims to make the cross-functional teams, streamlined teams, self-sufficient, and eliminates then the blocking dependencies of handover and decreases then the corresponding communication and coordination bandwidth between, including wait times and delays between teams. So far we have talked about the external customer-facing users and their user needs. But when we talk about team dependencies and ownerships, we can now switch from the external product view to the internal platform view, where then the teams are now representing our users. So when we switch to the platform value chain, that makes then now the streamlined teams becoming the users of the services that the platform teams provide. And again, we have to identify the users and also their related user needs. So in the streamlined teams, they have the user needs of provisioning and managing infrastructure, building, testing, releasing, deploying, operating, and monitoring the services of bounded contexts they are responsible for. And to fulfill these user needs of the streamlined teams, the platform team can provide a variety of platforms that then the streamlined teams can easily consume. For example, they can provide an infrastructure platform that enables then the streamlined teams to provision and manage the infrastructure for their services of bounded context on demand. And in general, the platform can start small, for example, with just like documentation, a wiki page, describing standards, describing best practices, and or templates, for example, with built-in security, and can evolve later in a digital platform with self-service APIs and tools. And built-in release platforms can support then the streamlined teams to build, test, deploy, and release the services the streamlined teams are responsible for. And as I mentioned earlier, a platform can also vary in its level of abstraction. So at a higher level, a platform can also reflect a design system, where then the platform team owning this design system can provide style guides, widget libraries, design principles, and so on. And to operate a monitoring service, the streamlined teams, they then typically require dashboards, alert mechanisms, incident management, observability capabilities, and these capabilities can then be provided by a platform team as operation and monitoring platform. So the platform team can provide a variety of easily consumable platforms with the focus of self-service capabilities, satisfying the user needs of the streamlined teams to make them self-sufficient and supporting them delivering the flow of work without constant interaction with the platform team, because it has focus on this self-service behavior, self-service capabilities. But another aspect to consider is for optimizing for flow is to identify and close capability gaps. And that's where the enabling teams can come in. So cross-functional streamlined teams, they need to cover a wide range of skills and capabilities such as software design and architecture, application security, user experience and accessibility, testing and QA, also software development, of course. And that is a lot to cover, where then the specialists of an enabling team can be pulled in on demand and upskill then the streamlined teams on missing skills to make them self-sufficient at the end. Or the enabling team can also facilitate the platform team by coaching them, for example, how to improve the developer experience for our platform, or how to design a scalable, reliable, and secure platform, and so on. And plus, the enabling team can coach streamlined and platform teams on skills that are also related to product management, because at every aspect we are dealing with a product, one product for external customers, and the other one, the teams like the platforms are then more internal facing products, but also the effective communication, good documentation, and so on. So enabling teams, they facilitate as internal coaches and also internal consultants, and help to upskill, streamline, and platform teams so that they become self-sufficient, which also then unlocks then the dependencies on people with a specific expertise to do something before the team can complete their own work. So they are unlocking the dependencies on people or teams with a specific expertise. But enabling teams also blend beautifully into the concepts of learning organizations. And learning organizations, they embrace continuous shared learning and experimentation. And continuous learning and experimentation, these are crucial aspects and for adaptability to be able to adapt and respond to complex situation with a lot of unknowns. And continuous and shared learning, that is on the one side can be supported by the enabling teams that helps to identify and bridge capability gaps of the other teams, helping them learning missing skills to make them self-sufficient at the end. Or continuous shared learning and experimentation is also supported by by a short-lived collaboration between teams in order to explore and rapidly discover uncharted domains together, or by a close collaboration between domain experts and development teams in order to create a shared understanding of the business domain as an essential part of domain-driven design in order to also align the software design with the business needs and the business strategy. And can also, beside like domain-driven design and team topologies, it can also be complemented with other team learning methods, for example, with establishing community of practices in order to exchange knowledge and develop expertise on a regular basis in a loosely group of people. So this architecture for flow approach aims to help us to unlock a variety of blockers to flow from the software architecture perspective, from the team ownership and the team dependencies perspective, and also trying to reflect also identifying closing efficiency gaps. And the question is how to start and how to bring these tools together. And I developed an opinionated, structured approach that I visualized as an architecture for flow canvas. And this architecture for flow canvas that reflects, on the one side, assessing your as-is situation, reflecting your current status quo, and also designs your envision to be situation, where we want to go. So what is our ideal future? And this canvas is not a rigid framework, I have to say. It just provides as little structure as possible and allows also to be complemented with other tools as well as needed. So, and it typically begins with the teams and the system of today, and then also envisions then the teams and the system of tomorrow representing the ideal future. And how to transition now from our as-is, from our status quo to our ideal future. And there, could be different approaches be followed. One approach could be a team-first approach as a reverse Conway maneuver. So Conway's law states that organizations, they design system that reflects or mirror their own communication structure. And the reverse Conway maneuver that suggests to restructure the organization in order then to achieve the desired architecture. And we can start, as we see here, we can start with the teams and the landscape of today with our, as we have addressed earlier, and can then apply then the reverse Conway maneuver through incrementally dynamic reteaming the current teams into our teams of our ideal future. And it's not enough to just reorganize the teams and then hope and cross fingers that something useful will follow automatically. We also have to have a vision of our ideal future that we want to achieve, and also have to actively adjust the system underneath. And for example, in this case, replatforming our infrastructure components from on-premise and environments to cloud-hosted services, and also refactoring our monolithic big ball of mud to split our system apart into our previously designed bounded context, and forming our teams along the way from the previous teams that we had. And also changing and evolving the team interaction between the teams in order to support the transition. So we have an evolution of interaction modes along the transition. And changing also the teams and the system in small steps helps us to gather early and constant feedback, and also to enables us to refine our envisioned ideal future accordingly. So it's not set in stone. We begin with an assumption of our ideal future, but along our transition, when we move forward in small steps, it allows us to gather feedback early and also adjust our system, our ideal future accordingly. So that in an ideal case that we were able to resolve our blockers to flow, applying then the reverse Conway maneuver with dynamic reteaming and an evolution of team topologies interaction modes along, in this case, along cloud migration journey. So coming to the end, so the combination of Wardley Mapping, domain-driven design, and team topologies helps us on the one side generating sustainable value that is aligned to the user needs, to address the building the right thing in terms of effectiveness, but also helps us to unlock blockers to flow in order to address efficiency. And it helps us to focus our development investments on our differentiators that provides competitive advantage. It helps us to identify potential efficiency gaps and close efficiency gaps, and helps also to align our teams in evolving their interaction to the system we build and the strategy we plan. And also helps us supports establishing a learning organization that embraces shared learning and exploration in order to be able to respond to complex situations with a lot of unknowns. So the combination of Wardley Mapping, domain-driven design, and team topologies does provide, in my opinion, a powerful tool set in order to design, build, and evolve adaptive socio-technical systems that are aligned to, that are optimized for a fast flow of sustainable value and a fast and constant feedback. And so that we are able then to thrive and to respond and to be able to adapt in the face of rapid changes, in order to also to build the right thing right in the end. And I also have some resources, just like an extract of resources that you can also dive deeper into this topic. And if you're interested in connecting the dots between them, I'm writing also a book about this topic. Thank you so much for listening, attending this talk, and I'm looking forward to your questions.
Great. Thank you, Susanne. Any questions? I have one, but maybe this time I'll give somebody else a chance to ask a question. Okay. Anybody? Okay. So my question, Susanne, would be around, and this is probably going to go into the panel discussion next, is around sense making. Like a lot of times what I find is challenges the organization is getting everybody to understand and get on the same page of what you just described in your talk. Like, you know, to a lot of people that are experienced, this makes sense. But how do we get that collective sense making or shared understanding in a company? And then how do we deal with personal aspirations? Like, you know, people that have a big ego and they're like, oh, this means I'm going to lose, you know, who reports to me or this. So maybe just your perspective on actually implementing this while dealing with challenges like getting everybody on the same page, and also obviously people's livelihoods would be impacted by these changes to optimize for fleet.
Absolutely. So first of all is that like to share the why of movement is also like across the organization. So why do we want to apply changes to why do we want to modernize our system, our team organization? And that is to have like to establish a shared vision of our ideal future can help in that way as well. But also what I like to do is I try to deeper the decision, like who is going to be in what team at the end to the very, very end. So, and usually I focus on, collective team design, so collaborative team design. So I typically work with the teams that are effective together. Go through this, like what problems do we have right now? So what are our blockers to flow, and so that everyone can say that what's holding them back, and then we are going to address like how we can address it together. So in terms of like how does the teams themselves see their ideal future facilitated in and supported in workshop sessions where we focus on the content, how to achieve it. And at the very end, then it's like where we'd say, okay, who's going be part of what team. So we try to defer the decision of team reorganization to the very end, focusing first to have everyone involved as well, and to address their to impact or to affect, influence the ideal future from their point of view, and bringing everyone together.
Right. So essentially, focus on the problem, focus on the bottlenecks, get the teams aligned on that, and then talk about what do we need to do and how we need to restructure. So goes back to what
Exactly.
you understand the current state, understand the problems, both from a customer as well as the employee perspective, I guess, and then talk about how do we reorg.
Yeah, I try to depersonalize it in terms of like, so what are the problems, and detach it then from the emotional, because for everyone it is like, specifically reorganizing teams has a lot of emotionally involved, a lot of feelings involved, right? So people don't like to get restructured a lot, which makes absolutely sense, because it's like yet another reorganization, and again dealing with this problem, and no problem has been solved, and also to identify the problem first, and have them involved in shaping their future.
So the idea of reteaming, and I guess it can be something that people shy away from, but it's also been done, like, with what Tesla has been doing, and like other companies, and like you referenced the book Reteaming. It is more common practice than people think, and I think maybe if we have that shared understanding of the purpose, like when I was talking to Joe Justice when he worked at Tesla, he said like it's very common for people to reteam every day around different problems based on what skills are necessary. But in a lot of organizations, that's again goes back to the structure. So I don't know, I'm just thinking out loud, but it is a challenge in organizations.
Absolutely.
Create an environment where people can self-organize and restructure the system based on what's needed and what problems are needed to be solved at any time. So
yeah, and it needs support from every aspect, right? It needs support also from management, from bottom up and top down. So from every aspect of the organization. Otherwise, at some point, we will just hit a glass ceiling and can't move forward.
Exactly, because there are certain changes that we cannot make, which is the question of then, like, if the leadership or executives or people with authority that are not supporting this, then you can only go so far.
Yeah.
You can. That's why it's not easy, I guess. So, any other questions? Anything else for Susanne? I've asked my questions and reconfirmed some of mine.
There's a question in chat, Milan.
Is it your question or somebody else's question? Because
somebody else's. It's Carl's question. A couple chats up.
Okay, I see it now. So it says, forgive me if this is a basic question. Where do operations fit into this model? For example, operating the platform product reacting to a live telemetry customer problems. Do you consider those streams unto themselves, or do you consider those as inputs that stream-aligned teams are expected to consume?
Great question. So yeah, what usually the streamlined teams supposed to operate their systems as well. That also means that they have their own like observability capabilities in place, like also including dashboards and so on, so that they can see what their services or what their bounded contexts are, what kind of errors are involved. Of course, there might be some incidents that are beyond the responsibility, so there still needs to be some operations, but usually the teams need to be able to span the entire from developing, from designing to developing to operating their system, deploying them, so that they don't have to interact with other teams in order to support the entire life cycle of their products, of their bounded context. But the underlying system, like if this is running, like that is then not handled by the streamline teams. That is then handled by platform teams. So that are specifically related. They have to their own bounded context that should be owned by the streamline teams.
Sorry, Carl, for missing your question. Hopefully that answers your question, or feel free to either post
Also
it.
contact me on LinkedIn or something like that. So I'm happy to answer that question as well if we don't have time for today.
Yeah. Great. Well, thank you, Susanne. This was really insightful. I do also look forward to your book, and thank you very much for taking the time this afternoon.
Thanks. Yeah, thanks a lot for having me. Thanks a lot.